If you are a space enthusiast or love mysteries, then you must have heard the term dark matter, along with all those myths that come along with it, like dark matter can allow us to use magic, but it might have left you in confusion whether to believe it or not. So, in our today's video, I am going to explain the concept of dark matter, what our current understanding knows about it, and how we can possibly utilize it in the future. To begin with, dark matter is a type of matter that makes up about 27% of the universe, yet it's completely invisible to our eyes and telescopes. It doesn't emit, absorb, or reflect light, making it undetectable by traditional astronomical methods. So, how do we know dark matter exists? Well, its presence can be inferred by its gravitational effects on visible matter, like stars and galaxies. Imagine a galaxy spinning in space. The stars and gas clouds within it move at speeds that suggest there's more mass than we can see. This hidden mass is dark matter, holding galaxies together with its gravitational pull. The existence of dark matter was first proposed by Swiss astrophysicist Fritz Zwicky in the 1930s. He observed that the galaxies within galaxy clusters were moving at much higher speeds than expected, suggesting that there was a large amount of unseen mass holding them together. Since then, a wealth of observational evidence has confirmed the existence of dark matter. Some of the key lines of evidence include the rotation curves of galaxies. The rotation curves of galaxies are the rate at which stars and gas orbit around the center. If we only consider the visible matter, the rotation curves should decrease as we move further away from the center. However, the rotation curves of many galaxies remain flat, suggesting that there's a large amount of unseen mass. The distribution of galaxy clusters. Galaxy clusters are the largest known structures in the universe. The distribution of these clusters on large scales can be used to infer the presence of dark matter, the large-scale structure of the universe. The universe is made up of a vast network of galaxy filaments and voids. The formation of this large-scale structure can be used to infer the presence of dark matter. Despite the overwhelming evidence for dark matter, scientists have yet to directly detect it. However, researchers are using a variety of experiments to try and detect dark matter directly. Some of the most promising approaches that our scientists have come up with are direct detection experiments, in which experiments use highly sensitive detectors placed deep underground to shield them from other particles. The detectors are designed to capture the rare interactions between dark matter particles and regular matter. Indirect detection experiments, where experiments look for the products of dark matter annihilation or decay, such as gamma rays, neutrinos, or cosmic rays. Particle colliders, where Large Hadron Collider are used to create high-energy collisions that may produce dark matter particles. Theoretical physicists also play a crucial role in understanding dark matter. They develop models and simulations to predict how dark matter behaves and interacts with other particles. At present, we have some famous theories on dark matter, like the WIMPs, weakly interacting massive particles, are particles that interact with normal matter only through the weak nuclear force and gravity. Axions, which are hypothetical particles that were first proposed to solve a problem in the standard model of particle physics. Sterile neutrinos, which also are hypothetical particles that don't interact with normal matter through any of the fundamental forces. These three hypothetical particles are popular candidates for dark matter because they would have been created in abundance during the early universe. In our current understandings, Dark matter is essential for the formation of the cosmic web, the large-scale structure of the universe. It acts as a scaffold, guiding the formation of galaxies and clusters of galaxies. The search for dark matter is an active area of research, with scientists using a combination of experiments, simulations, and theoretical models to better understand this mysterious substance. As we continue to explore the mysteries of dark matter, we may unlock new insights into the fundamental nature of our universe. And maybe it really led us to discover a way of using magic